My name is Tribhuvan Singh, and I welcome you all in SOA Weekly Academic Lecture 5. And so, first of all, let me start with a brief introduction with a video. And this video is of 5 minutes, and then we will continue. Okay, thank you, sir. And okay, once again, I welcome you all in SOA Weekly Academic Lecture 5. And the topic of today's webinar is an implementation a perspective of blockchain through the Bitcoin. And our speaker is Dr. Tarun Kumar, sir. And Dr. Tarun Kumar sir is currently working as an assistant professor in the Department of Computer Science and Engineering, School of Engineering and Technology at Central University of Rajasthan, Ajmer, Rajasthan. He has more than 6 years of teaching and research experience. Dr. Tarun received his PhD degree from MNIT Allahabad, Prayagraj. He has published more than 25 papers, chapters in various reputed SCI, Scopus, Web of Science, ESCI index journals, and conferences. Dr. Tarun Kumar is currently working on deep learning and blockchain technology. Now I request Dr. Tarun sir to share his screen and continue his presentation.
Thank you. Am I audible?
Okay, thank you, sir. Yes, sir, you are audible.
Screen is visible.
Yes, sir, screen is visible.
So first of all, thank you, Dr. Kumar. I would like to thank Dr. Madhuri and head of the department inviting me for such wonderful webinar. So as decided, today I will present an implementation perspective of blockchain through the basic design of the Bitcoin. And this is the need of the today's because when we talk about the blockchain and development of the blockchain applications, so there are two ways. One is in the form of the smart contracts. So smart contracts, so we can develop the smart contracts in the various different languages like Solidity and in Java. And in order to deploy that, we have to use the third-party blockchain network like Ethereum and all of them. And we have to deploy our smart contract onto that particular network. And the complete applications is managed by the miners, which is the part of the Ethereum and different kind of third-party blockchain platform. So this is the one way and the easiest way of the blockchain application development. But the second thing is what if you want to design a blockchain application from the scratch? Okay, from the scratch, that means you have to design all the things, all the related technology and integration of the modules from the beginning. Okay, so this is very important thing because if you talk about the research and challenges, that is comes when we have to design such kind of structure from scratch to the application. And through this session, I would like to explain the design of the Bitcoin. Bitcoin is the very first cryptocurrency which is proposed by the Satoshi Nakamoto, and in 2008. Okay, and this is the basic of the all the different kind of cryptocurrencies and the concept of the blockchain as well. So through this session, I will explain the concept of Bitcoin, and I would also like to discuss the challenges you will face when you develop your own application on the blockchain. Okay, so first of all, I will start from the Bitcoin. Okay, so what is a Bitcoin? And I hope all of you are aware that this is a cryptocurrency. Okay, so the Bitcoin is a distributed, decentralized digital currency system which is based on the blockchain. Okay, so the thing is, this is a distributed into the different of the nodes. Okay, and the second thing is this: this is a decentralized. Decentralized means there is no centralized control on the policies and on the any of the policies of the completely cryptocurrency. Okay, so again, this is similar to the different banking projects or banking systems. Like there are digital checks, there are distributed transaction logs, and these transactions are stored into the ledger. So what are the transactions? So when we talk about the simple banking system, and if someone want to transfer some money to the another account, another person, okay. So in the background there is a some just a kind of transaction is there, and it is stored into the some system. Okay, this there is nothing from some like physical transform of the assets from one person to another. So this is just a transaction, and which is stored into a particular system. Okay. So Bitcoin is a similar, and the transactions here are stored into the distributed peers. Okay, and in the banking system there is a centralized control of the particular authorities on the all the transactions, all the policies we have to agree on the particular centralized authority. But in the Bitcoin, there is no centralized authorities, and there is all the peers are equal, all the nodes are equal, and each one have the same kind of transaction. So the transactions in the Bitcoin is stored into the ledgers, and ledgers are stored into the blockchain. The blockchain. So if we talk about what is a block, it is a collection of the recent and verified transactions, and Bitcoin uses cryptography to control its creation and the management of the block. And in any blockchain application, a typical block can have three components, which is the necessary. One is the hash of the previous block, second is the data, and third is the proof of work. Okay. So data, which is the transactions, if you talk about the blockchain, Bitcoin, there are some transactions, and transactions are stored into the particular subsection. And the very first block header is the previous hash. So just like we have a concept of linked list in data structure, where the nodes are connected, linked to each other, where each node has the address of the next element. And from starting, we have the address of the starting nodes. And from that particular starting node address, we can traverse the complete linked list. Similar things is happen into the blockchain, and where each block is linked to the previous block. Means each block has an indexing of the its previous block, and we have the hash of the last block. And from this hash of the last block, we can traverse the complete blockchain, because the blocks are linked from the hash. Okay, so this hash, basically this is the cryptographic hash. I will discuss the later about this. This is the cryptographic hash, and this particular block is linked with this index from the previous one block. Okay, so the hash values are used as an indexing of the blocks in the blockchain. So blockchain are inherently decentralized system which consist of the different actors connected through the peer-to-peer network, and who act on their incentives information available to them. Okay. So as I say, this is a decentralized system. So what is the meaning of decentralized system? Means the nodes, the underlying architecture of the blockchain network is the peer-to-peer network. Okay. Peer-to-peer network, which is different from the client-server network. In the client-server kind of network, there is a
Sir,
server.
actually, the first page, excuse me, sir. Only the
Yes,
first
yes.
page is visible, sir. I think the page is not rolling down. Only the first page is visible.
Actually, I am changing the slide. This is the fourth slide.
Yeah, but we are able to see the first slide,
So what should
not
I do?
fourth one.
Uh,
Sir, I
okay.
think
Uh,
next.
okay. 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 Let me try. Okay. Uh, let's go. I think it is. Is it visible?
Yes, yes, sir.
And now,
The yeah, now it is yes. What is Bitcoin, right?
yeah, yeah.
Yeah.
So should I repeat or continue?
No, no, sir. Continue, sir.
Oh, okay. So I'm talking about the block. Okay, so this is the typical structure of a block, where we have the hash of the previous block and transactions and some proof of work. This is the consensus technique I will discuss later in this slide. Okay, and the hash values are used as an indexing block into the blockchain. Okay. So I'm talking about this blockchain. It is a centralized system in which the underlying system is a peer-to-peer network. There are two kind of systems are there. The client server network, which is the typically in the centralized system like banking system. There is a server, and all others are the nodes are the client nodes, and all the nodes accessing the information from the server. Server is the service provider. But in this kind of system, all nodes are equal and all nodes are connected from each other in the equal capacity. All nodes have the complete copy of the blockchain and they are connected to each other. So why these are connected with each other? Why they have to spend so much storage to store the complete blockchain? Because they will get the incentives to manage that particular information, and they to perform the validation and other kind of the task into the blockchain. So they will get the incentives from the networks, and they work only on the information, whatever the information they get, they work on that particular information. And for the each transaction, consensus is calculated based on the majority, and we decided the complete state of the blockchain. Okay. So if you talk about the typical structure of the blockchain, it looks like this. So where the block 3 is the largest, in this figure, you can find out that the block 3 is the last block, and from in the last block, I have the hash of the block V2, and from this hash, this is act as an index, and I can access the content of the block 2 by using the hash of the block 2. And when we come to the block 2, and it has the hash of the block V1, and this is again act as an indexing, and uh, with the help of this indexing, we can access the block 1. So this is how the blockchain networks, blocks are connected into the blockchain. Okay. Now, the very first issue I will talk about as I say, that blockchain is underlying architecture is a peer-to-peer network where the different actors are connected to each other to perform their particular task. But what happened when some of the node or actor decided to not to follow the rules and tamper with the state of his ledger? So the first thing about the blockchain is that a copy of the blockchain will be available to all of the nodes into the network. First thing. Now each node have to perform according to the predefined rules. Now, there may be some nodes which are the malicious nodes, and they want to try to tamper the state of fertilizer. So, how to deal with such kind of situation? And what happens? There are some number of the nodes, such kind of nodes, that are trying to violate the state of the ledger. So, what will be happen, and how the deal with this particular kind of situation? And the Bitcoin uses Byzantine fault tolerance system characteristic to deal with the such kind of scenario. So I will explain very briefly about the Byzantine general problem first. Okay. So this is a problem, classical problem, which is called Byzantine general problem. This is the solution of the given issue. The issue just I discussed before. This is the solution of that particular issue. So the problem is that there is a Byzantine army, and each army is divided by some units, and which is commanded by some general. So the requirement of this army is that all loyal generals decided upon the same plan of the action. So they have to perform some action on some territory or some area, and all generals decided that we have to work on this particular solution. So requirement about this problem is that They all journals should work on the given plan. So they have to follow the same rules and action on the particular time. Okay. And second thing is that if some number, there may be possibilities that some journal may be traitors or some lieutenants may be traitors. In that case also, we have to go with the decided plan. Okay, this is the requirement of the Byzantine journal problem. So means any whenever we decide some task, then we have to perform on that particular task. So if there are some traitors, then still we have to follow the particular task. Then how to deal with the such kind of traitors? This is the similar kind of issue that arise in the blockchain, where some nodes are trying to violate the state of the ledger. So how to deal with that? The one example is that there is a mechanism like voting mechanism. Suppose this is the scenario. Here the commander is the loyal and the lieutenant 3 is the traitor. Okay. Now commander issue some commands to the all the lieutenants like command B to lieutenant B 1, command B to lieutenant 2 and command B to lieutenant 3. So each lieutenant have to decide what she should do based on the commander, because there may be possibilities that commander may be traitor or some lieutenant may be traitor. So they perform some voting like mechanism, like whatever the instruction received by lieutenant 3, it have to share with the lieutenant 2, because it is a traitor and it wants to interact with the interact the lieutenant 2 as well. Okay. Now, Lieutenant 1 also says that whatever the mass command is received from the commander from the Lieutenant 2. Now, Lieutenant 2 has three votes. One are saying there is a command from the commander is the B, and another one is saying there is a command from the commander is X. Now, Lieutenant decide based on the majority that I have to follow the particular command, because the majority is saying we have to follow the command B. Okay, so that's why this is how it ignores the malicious node, like traitor tra- traitor lieutenant 3, similar to the in the blockchain network. That's why they ignore the malicious node into the network. Second thing is that what if the commander is itself is a traitor? So if the commander is a traitor, then in that case, commander will issue the different command to the different lieutenant to get them confused. So commander will issue the X command to the lieutenant 1, a Y command to the lieutenant 2, Z command to the lieutenant 3. Now how lieutenant will decide that what should they have to follow? Okay, so they share their message, commander message from each other, and based on the vote, they decide that each one of them getting the different kind of message from the commander. So they uh, understand that commander is traitor and they have to follow the decided plan. They have to go with the decided plan. So this is the Byzantine general problems, and this same solution is applied into the Bitcoin, where the characteristic is introduced in the network, which is the Byzantine fault tolerance. Byzantine BFT is the characteristic which defines a system that tolerates the class of the failures that belong to the Byzantine general problems. Okay. And the consensus algorithm is the Byzantine fault tolerant as long as the number of the traitors do not exceed on the third of the journals. So the thing is that it is computing the majority of the vote. And if the number of the traitors exceed from the comes into the majority, then the all node will perform according to the majority. So the system is the fault tolerance up to the when the loyal nodes are the in the majority, and there may be some nodes that may be traitor, and so we can ignore them. Okay, so this is similar kind of the situation is there. So in the blockchain network, some nodes may be there, and it is a very big network, and it is very difficult to take over the majority of the nodes, like 51% of the nodes, and in fact them as a malicious node, and to take over all the blockchain. Okay, so this is the very difficult task, and till now the blockchain network, Bitcoin's network is the unhackable. Means due to the malicious node, it is not hackable. Hack till now. Okay. Till now. Okay. So as I discussed that this particular problem BFT is solved the blockchain problem of the malicious node into the blockchain. Okay. So due to the value stored in these ledgers, bad actors have to use economic incentives and have to face the fault. The solution to the Byzantine general problem for blockchain is much needed. In the absence of the BFT, a peer is able to post the fault transaction effectively and nullify the reliability of the blockchain. And if the BFT is there, then we can tolerate the such kind of nodes into the blockchain. So so the first thing, when we try to develop a blockchain application from the scratch, we have to design a peer-to-peer network, and we have to introduce BFT characteristic into the network so that if any one of the node is a fault or a malicious node, and still our network is remain reliable, and the transaction remains the mutable transaction. Okay, so this is the first thing we have to deal with the issue when we try to develop a blockchain network from the scratch. Deal with the malicious node into the peer-to-peer network. Okay. Second thing we discuss about in this session is the consensus algorithm. Okay, this is the very important part of the blockchain, any blockchain network. After the designing the network, we have to design some consensus algorithm mechanism. Okay, so what are these consensus mechanism algorithms? So blockchain uses consensus algorithms to elect a leader who will decide the content of the next block. Okay. And this leader is responsible to broadcasting the block to the network. So what is the scenario here? Okay. So now, as I say, there are lots of the nodes joining into the network. Okay. And there is an incentive so for the designing of the new block. So to create the new block into the network, they will get some Bitcoin. Okay. Now the thing is that whenever the transaction is there, all nodes will compete for designing a new block. Okay, and if the all nodes are able to get access to design the block new block, then there may be unsynchronization into the blockchain. And in any case, we have to make the synchronized blockchain. That means the same copy should be available into each of the nodes. To block this competition, they have to decide, elect a leader at particular time. So whenever the transactions are arrived, and in order to store these transactions into the block, they selected a node as a leader, and leader node will convert them, store that transaction into the new block, and then broadcast the new block to the all of the uh, remaining nodes. Okay. So how the problem is that how to elect a leader, because everyone wants the incentive. Okay, because every participants need the incentive. So how to decide? There should be a mechanism to elect a leader that can that is responsible to generate the new block and broadcast into the network. So Bitcoin uses proof of work. Bitcoin uses proof of work algorithm. Okay. In the proof of work, whenever the transaction is there, okay, so there is some puzzle given to the nodes. Okay. There is some puzzles given to the node, and each node will try to solve that particular puzzle, and the node which solve the puzzle very fast is elected as a leader, and rest of the nodes have to check the solution generated by the leader node. And now this leader will mine the particular block from the by adding the transaction into the block and broadcast the newly elected generated block to the all the remaining nodes. And all the remaining nodes will verify the transaction and validity of the solution given by the leader node. Okay, so what kind of puzzle is there into the proof of work? So basically, there is a hash function is used into the cryptographic hash function, which is generated like a secure hash algorithm 256. This is the algorithm is used to generate some kind of puzzle. Okay, So proof of work, in the proof of work, a mathematical solution to ensure that it is a valid block hashing is used in the proof of work. A hash function is any function that can be used to map the data of arbitrary size of the data of the fixed size. So in this is the uh, thing into the hash function, that whatever the data I will give into the hash function, it will generate a unique hash sequence, a unique hash value. Okay, and this hash value is unique for all kind of combinations. Whatever the size of the data I am giving to the hash function, it will generate the fixed size of the data, and that will be the unique. And this is the one-way hash function. Means by by analyzing the hash value, we cannot determine the content of the hash content of the that particular value. So a solution is given like this, what kind of puzzles are given into the Bitcoin whenever they have to mine the new block. So in order for an actor to be elected as a leader, they have to find a solution to a particular mathematical problem. For example, let the problem be there is a data x. There is a data x. Now the problem is that find a number n such that the hash of n appended to x results less than y. This is the solution. Now I have to find, in order, if I want to mine the particular block, I have to find the value of this n, what value I add to the x, so that my result will get less than y. This is a puzzle, and every node have to solve that particular puzzle. So this is an example. So hash of the this like x is the test, this is our data, and if I compute the hash of the test, I get 15, which is the greater than 10. That means the puzzle is not solved. Now I add 1, take the value of n is 1, and then compute the hash of the test 1. Now I get the another value, which is again the greater than 10. So this is the puzzle is not solved. And then I increase the value of n, and then again compute the hash. And then the point where I get the solution which is less than y, which is the 10. Then I can say that my puzzle is solved, and the solution of the puzzle is the 2. Like I will add the 2 to the data, and then I get the desired result. So the node which solve this particular puzzle means the node which finds the value of the n very first is selected as a leader, and this is the responsible for creating of new block, and then uh, it broadcast that block to the remaining nodes. And all the remaining nodes will check for the solution generated by the leader node and verify the transaction into the given broadcasted block. And in the response, the leader node will get some Bitcoin as a transaction fees, as an incentive, as an incentive. So this is the how the proof of work is work. So so the second thing is that when we want to implement the blockchain, the first of all I have to design a peer-to-peer network, and I have to make sure the peer-to-peer network is the Byzantine fault tolerant. Okay. Second thing is that in order to develop any application, I have to design a consensus mechanism, because there are so many consensus algorithms are there. Proof of work is there, proof of stake is there, proof of ESP is there. There are so many algorithms are there, and not every problem, every algorithm is fit to the every application. Okay, because every application have their different domains. Okay, and because they in this proof of work, every node have to solve the cryptographical puzzle, and this is very difficult and requires so much computation power. Okay, and each transaction is required around 15 to 30 minutes in order to get added into the blockchain. Okay, so time is there. So we have to think about the consensus algorithm as well when we design. We have to design the particular blockchain from the scratch. So peer-to-peer network. Second is the consensus algorithm. Now, now I will discuss the typical blocks of the Bitcoin. Bitcoin, how the block is there into the Bitcoin. So this is the particular block into the Bitcoin. So there are so many components are there. I will explain you very brief. There are magic number, which is an identifier for the blockchain network. It is a constant. block size, which indicate the size of the total block. Then there is a previous block hash, which is the 32 bytes that is contain the hash of the previous block. Okay. Then there is a Merkle root. Merkle root, whatever the transactions we have to create a hash tree of that particular all the transaction, and we have to store as a Merkle 2. Then we have timestamp at which the block is created. Then difficulty target, the how the puzzle is difficulty. Difficulty is there. There is some number to represent the difficulty level of that particular puzzle. Nonce is the solution to the puzzle. What is the number on what particular number the puzzle is solved. And then there is a counter. How many transactions are there into the block, and then list of the transactions. This is the typical structure of a Bitcoin block. So this is an example of the computing the Merkle root. Suppose there are three transactions, and then the first level, in the first level, we have to compute the transaction of the very first hash of the first transaction, then hash of the second transaction, then hash of the third transaction. Then at the second level, we have to compute the hash of the lower level of the transaction, like hash A and hash B. This is the another level of the hash. And if the transactions are the odd number, then we have to replicate the remaining transaction with this. Like SC, there is no other transaction, then we have to replicate the hash of this layer and compute the next level of the hash. And at the top of the layer, this is the hash of the all the particular transaction. So due to this hash, the all each transaction becomes the immutable. Immutable means if anyone tried to change any of the transaction, then it have to change the complete hash tree, the complete hash tree, and it has to change the Merkle root, which is the practically impossible. So this is why all the records in the blockchain are the immutable. So we have to deal with the such kind of. This is the example of the SHA algorithm where I can put one character, then I will get 32-bit byte output. Then any of the characters I can give, it will give the fixed size of the output hash value, and each hash value is a unit. Each hash value is a unit. So this is the backbone of any of the blockchain network. Okay. So all the previous hash we compute with the use of the hash 256 algorithm. This is the typical blockchain into the blockchain in a Bitcoin. So this is the how it is stored. So each block into the blockchain, Bitcoin blockchain, contain the hash of the header of the blockchain. Header of the blockchain. Now the mining is the another process. So we call the Bitcoin mining as a bookkeeping, which is the process. The leader node will perform the mining and that validate the transaction and get rewards for the block generation. Okay. So Bitcoin miners run a software program called Bitcoin called on their host machine. Okay. So you must have heard about that there are some mining farms. So they are computing devices running connected with the Bitcoin network, and they are running the Bitcoin protocol software. And they are trying to solve the puzzle very fast, so that they get chance to mine the block, so that they can receive the Bitcoin. They can receive the Bitcoin. So now the blockchain implementation. Now, what are the things we have to deal when we have to develop an application from the scratch? First of all, as I say, we have to decide the peer-to-peer network, and peer-to-peer network can be a different type. Like one can be the public network. In public network, like anyone can join anytime, or anyone is free to join the particular network. Second is the private kind of network, where the each node, our network is the private network, and each node is the authenticated node, and only authenticated node can join the particular network and perform the Bitcoin transaction. Because the one thing is there, the blockchain is stored on each of the node. Means each node will have the complete list of the data. So there is some privacy issue can be there. So if you are designing an application where the privacy is concerned, then you have to ensure that the node into the network must be the authenticated node. Because if there will be the public, there will be public network, then anyone can join the network and can deal with the data which is related to the privacy of the some other node. Okay, so the first thing is there. So there is another kind of network which is called the hybrid network, where the some nodes are the authenticated nodes and some of the nodes are the public nodes. Okay, and the authenticated node have some power, like they can mine the block and other thing, and the public node can have just access to the node so that they can verify the certain number of things. Okay, in last year we have published a paper like we have proposed that e-check system for the banking transactions based on the blockchain, where we have proposed the design of the network which was the hybrid type of network, where the banking nodes from the bank sides was the authenticated node, and some private players can also connected with the network with some authorization, and they get incentive for each transaction. Okay. Second thing is the consensus mechanism. We have to work on that. But if we are in the research on the blockchain network, we have to deal with the, because blockchain application development from the smart contract is very easy. Okay, we don't have to deal with such kind of things. But when we are in the research and we are designing a particular application where we want to create our own network, we don't have to depend on the third party of network, because we have to pay third party network for every transaction. Okay, so in that particular scenario, we require such kind of thing. So consensus mechanism is the another thing we have to work upon. Okay, and then public and private mining. So mining rights we should given to the particular node or line. Then there must be some authority servers like that issue some authentication or details or authorization to the particular nodes. And like in Bitcoin, whenever each node become the part of this particular network, so they will get some public and private key. And public key is shared with the all other nodes of the network, and the private key is kept secret by the particular node. So all the transactions generated by that particular player are digitally signed by his private key and verified by the public key given by the all the nodes have the public key. Okay, so we have to deal with the such kind of system. Now, if you want to try the development of blockchain from that, how can you start? So I will discuss in very brief a platform which is can be helpful for designing a blockchain application, which is called the IPFS, Interplanetary File System. Interplanetary File System. This is a uh, very we can say open source concept, and it is very easy that manage all the networking like things very easily. Okay, so interplanetary file system is a peer-to-peer distributed file system that seeks to connect all computing devices with the same system of the file, and as well as IPFS provides a high throughput content address block storage model with the content address hyperlink. Okay, so as I say, on the underlying architecture, there is a peer-to-peer network, and indexing of the blocks is happening from the hash value of the particular block. Okay, so IPFS provides this particular basic facility for you. Okay, so whenever you want to design a blockchain application, you can use IPFS network, where it provides the simplest way to create the peer-to-peer network. We can connect with each other in the peer-to-peer manner, and we form a swarm network. Okay, means every peer can connect with the send message to the any one of the peer, and they share the same kind of file system which is required into the blockchain, because the format of the block, the structure of the block should be same into the each of the system. So it provides the same system of the file. Also, it provides a very high throughput content address block storage model. What is this? So whatever the blocks we are putting into the IPFS, it generates the hash of that particular block. And as an index that means by using that particular hash, I can access the data of that particular block, which is the primary requirement of any blockchain network. This is the primary requirement of the any blockchain network. So this forms a generalized Merkle DAG, a data structure upon which one can build the virtualized file system and the blockchain. So as I say, the Merkle root is there. So this is again, it can store the transaction into the Merkle DAG representation, and we also can implement the version-based file system into the blockchain. Like GitHub, you must have heard about the GitHub, which is the version control system, where you can manage the file, whatever the changes you are doing, and based on the versions. Okay, the IPFS you can do the same kind of thing. You can maintain the versions of the different files, and blockchain is also required a similar kind of thing. And the most important thing is that IPFS has no single point of failure, and nodes do not need to trust each other. Okay, this is the again requirement of the blockchain. Nodes are the peer-to-peer, and we don't have to trust the node because the itself the policies of the application of the blockchain is the manage the all the trust and reliability issues. Okay, and IPFS has no single point of failure because this the network is the distributed. So it is a peer-to-peer. No nodes are the privileged. IPFS node store IPFS object in local storage, and nodes connect to each other and transform objects. These objects represent the files and other data. IPFS protocols have different kinds of sub-protocols, like identity management is there. We can generate the public and private key for the each node, and we can verify them. Okay. Network protocols are there, manage the connection between the peers and using the whatever the network layers we have. Okay, whether we have LAN, whether we have WAN, so it manages, it work on the top of the underlying network protocols. Routing is there, maintain information to locate some special and clear objects. Okay. Exchange, a novel block exchange protocol that govern efficient block distribution. Okay. And objects are there. We can create a Merkle DAG of content address immutable object with the links and used to represent the arbitrary data structure like file hierarchy and communication system. So this is an example. If anyone of you is interested, like I want to show you how this can happen. Suppose I have create a transaction in a particular file which is called the block1.txt. Okay, and I have a complete network of the IPFS. Okay, underlying thing. So if I put the command like IPFS block put and give the particular file name, so it file stored into the IPFS in a form of the block, it generates the hash value of that particular block. Okay, and I can use this hash value as an index to retrieve the data from the particular hash value. Okay, so like in this example, you can see the IPFS block put. When I run this particular command on the IPFS, then it in return it will return a hash value. This is the hash value. And if I use this hash value, any of the peer into the network, like I have 100 nodes connected with each other using the IPFS. And if I use this hash value on the any of the peer, I will get the content of whatever the data I stored into that particular block. So for that purpose, I have command like IPFS block get, and I will put the hash value of that particular block, and I will get the data which is stored into the block. Which is stored into the block. So this is how the IPFS provides the under basic minimum infrastructure that is required to create the blockchain application from the scratch. Okay, and the beauty of this IPFS is that you can use any of the programming language, like you can use C to handle the block creation and mining process, consistent mechanism, all that. You can use Java, you can use Python, and there are some APIs is also available, which is on the Node.js platform. Okay, so and apart from the blockchain, you can do some decentralized web development on the basis of the IPFS. You don't require a particular web server to host a website. Okay, you can use host any static website on the IPFS, which is the distributed. And you don't require a particular server. Okay, it is also provide some peer-to-peer databases on as well, where we can use a different node to store our data. Okay. So this is the IPFS. So from this, I will end my session. I hope it is within the time. Okay. And any query related to this method, over to you, Dr. Kumar.
Thank you so much, sir, for such a nice presentation. Okay, so is there anybody who is having some queries? Yes, anyone has any query?
One more thing, if some of your students are interested, I would like to share that in the Central University, I have created a community like CURAG open source community on the GitHub. Okay, so if you search on the GitHub, you will find that particular community. There have I share the code of the blockchain, basic blockchain, which is work on the IPFS. Okay, so this is the code which is created and developed in the Java. That is available there, and there is another material which is related to the digital how to get signed transaction digitally using the private public key and verified private key and verified by the public key, which is also available on the GitHub. Anyone can go to that particular library and can search for the particular content if anyone is interested. Thank you.
Any query? Okay, so thank you so much, sir, for a nice presentation. Yeah, it was really amazing. Yeah, actually there is a query from Madhuri ma'am. What simulation tools can be used?
So as I say here, IPFS is the tool that is providing underlying architecture, and apart over on the IPFS, you can use any of the programming languages to develop your application, and you can analyze from that what are the network things are there, like generating the simple Linux commands, whatever we have for the analyzing the network, analyzing the resource utilization, all the things we can do with the simple tool that is available in the Linux platform. And one thing also there, this IPFS is a platform independent. Means the same things, the same command will work on the Linux system, Mac OS, and the Windows. You can use any of these systems. So means the any node can have any kind of operating system. It's independent to the operating system.
Sir, so okay, so on behalf of the Department of Computer Science and Engineering, Institute of Technical Education and Research, Shiksha Anusandhan, I extend our heartiest thanks to Dr. Tarun Kumar sir for delivering such a nice presentation in a simple yet elegant talk from his busy schedule. The webinar was really wonderful. I would also like to thank the organizing team of the CSE department, our HOD ma'am, Professor Debahuti Misra ma'am, who is the convener of this lecture series comprising of 52 sessions, today being the fifth one. And last but not the least, thanks to all participants for their patience and joining this webinar. So thank you all. And yes, Madhuri ma'am. Hello.
Sir, am I audible?
Yeah, yes, ma'am. Yes, ma'am. You are audible.
Sir, thank you so much, sir, for such a wonderful webinar, sir. We have been listening, and sir, students want to get in touch with you, I hope we could reach you through Tarun, sir. So,
Yeah. I have shared my email ID.
sir,
Yes.
sir, and any possible further collaboration, sir, we would like to get in touch with you, sir.
Yeah. I have shared my email ID. You can get in touch with my email ID. Tarun.kumar@civas.ac.in.
Sir, sir,
Okay.
thank you so much.
Okay, sir. Okay, sir. Thank you so much, and thank you all.
Okay.
So, we should leave now.